Very, very quick. So all this is about today is kind of strategies for solving quadratic. So here's our checklist of the things we're going to try, right? So when we solve a quadratic, the first thing we want to look for is we want to see if we can point to a single x. Now, if we can point to a single x, then what's that mean? Well, we can just use inverse operations, right? Write down the PEMDAS tree and go bottoms up with the PEMDAS tree, right? And just isolate the x by using inverse operations. That's easy, right? That's the easiest way to solve any equation. But you can only do that if you can point to a single x. A lot of times we can't do that, so we have to move on down the list. Okay, what's the second option? Well, solve by factoring in the zero product property, but only if it's really easy, right? You're only going to do this only factor if a is equal to 1, right? So the number in front of x squared is 1, and magic numbers are easy. Right? And then solving by factoring is a pretty easy way to go. But what can you always do? Anytime you're solving a quadratic equation, there's always an option that works every time. What is that? Quadratic formula. Yeah, this is this is always going to work. But sometimes there are just some easier ways to do it, right? Because the quadratic formula means you have to plug a lot of numbers into a formula. It's not that hard to do, but I mean, there's a little bit of computation there, and sometimes it's really easy to just use a different technique instead, just quicker and easier, right? But you can always use it. And if either of the first two options are not good, then just jump to 3 and use the quadratic formula. Okay, so let's look at just 3 quick examples today. So what about one like that? Is that quadratic? It's not the way it's written, right? What's wrong with it? Why is that not quadratic? Okay, good, because of the 4. Yeah, because of the exponent, right? For it to be quadratic, what would the exponent need to be? The biggest? That'd need to be at 2. Okay. So is there a way here where we could maybe make a little substitution that would turn this into something that looks quadratic? Could we trade, like, what do you think? Any ideas? Like, could I trade for a new variable? What if I let x equal what? Phone should be away, please. P squared. Yeah. Right? If I let x equal p squared, what does that turn this equation into? What would p to the 4th become? X squared, exactly, because p squared would be p to the 4th. Everybody see that? Okay. So we could just turn this into x squared minus 81 equals 0, right? Okay, so how does that work? What could I do there? Yeah, I could do difference of squares, couldn't I? Right? Because 81 is just 9 squared. Agreed? And we know that one. We've used that one probably about 1,000 times. How does that factor? X squared minus 9 squared factors into good, x plus 9, x minus 9. Okay. Either order, it doesn't matter. And so now by the zero product property, right, I've got this whole thing equal to 0. What are the values of x that would make this true? Okay, good. So what's the solution of that first factor? 9, good. So either x equals 9 or x equals negative 9, right? Are we done? No. What do we have to do? Oh, we got to go back, don't we, right? Because look, we made this substitution. Our original problem was in terms of p's, not x's. So I got to flip back to p's. So if I change that x back to a p squared, I either get p squared equals 9 or p squared equals negative 9. So what's the one step I would need to solve that first equation? Everybody agree? All I have to do is square root both sides. Can I point to a single p there? Yeah, right? So I can use inverse operations to isolate the p. The only step I need to isolate the p is square rooting both sides, right? Square root to undo the square. Okay, so then what do I get if I do that? P equals,
Plus or minus 3.
okay, 3 wouldn't be correct, right? How come I need the plus or minus? I mean, I guess that's kind of a, just because, right? If I square root both sides of an equation to solve it, I always need to include that plus or minus. So it's the square root part that's telling me I need that plus or minus there. So how many solutions did we just get? Two. Plus 3 or minus 3, right? Okay, or what about over here if I square root both sides? That cancels the squared, and I get P equals, okay, but what's going on here? Square root of negative 9 becomes what? Yeah, what's our rule? A negative inside a square root becomes I outside. Okay, good. So then we end up getting this negative is going to be an I outside. And what's the square root of 9? 3. So is that right?
No, plus or minus.
Plus or minus. Again, I have to have that plus or minus, right? Because we square rooted both sides. So I need that plus or minus. Now, how many total solutions did I get? The total solutions. 4. Yep, good. I got 2 here and 2 there. What are all the values P could have? Well, it could be positive 3, negative 3, or positive 3i, or negative 3i. Okay, make sense? So did you have to make that substitution? I think it's easier to do that, but there is another way we maybe could have done this that we talked about earlier in the year, right? How could I write this expression as something squared minus something squared? Well, you already told me 81 is just 9 squared. P to the 4th is what squared? P squared, okay. And then I could just factor that directly, couldn't I? Right, I get something squared minus something squared. So I know I'm going to get that kind of a pattern. I know that's going to be a minus 9 and a plus 9, but what would go there and there? What would it be?
P squared.
Yeah, whatever's being squared here, which is a P squared, right? So I get P squared minus 9 times P squared plus 9. And where would that take me? Well, okay, so P squared minus 9, this is all equal to 0, right? So if I set P squared minus 9 equal to 0, what would the solution be? Well, it would be P squared equals 9, right? It would have just got me there, wouldn't it? And how about this one? P squared plus 9 is 0 when P squared equals negative 9. So I could have done it that way, but don't you think it's a little bit easier making that substitution? I think it's a little bit clearer when you do, but take your pick, right? Okay, give me 1 to 5 on that. How we doing? Does that make sense? Good job. All right. Okay, what about one like that? Anybody see a substitution that might be useful here? X squared. Yeah, let something equal x squared, whatever you want to call it. Let's just call it y, how about? If I let y equal x squared, that helps because what is that first term going to become now? 4y squared, right? I'm going to trade, if I trade a y for an x squared, then x to the 4th would be the same as y squared, wouldn't it? Right? Plus 23y equals 6. And now that's good. Look, now that looks like a normal quadratic equation that I can solve using all the stuff you guys have been practicing, right? So what would I need to do to solve that equation first? Subtract 6. I got to put it in standard form, don't I? So we get 4y squared plus 23y minus 6 equals 0. Good. Okay, so now go through the checklist here. What's the easiest way to solve this? Vote with your thumbs. Can I point to a single y? No, I can't. Look, there's y squareds and y. So can I isolate y? Can't, right? Because the only way I could isolate y is if I could point to a single y, which I can't do. So I don't have that option of using PEMDAS, inverse PEMDAS, right? Reverse PEMDAS. So that one's off the table. Would this be a good one to factor? Heck no. How come? What makes this a really ugly factoring problem? The 4. Yeah, we don't want to factor this if I've got a number in front of the y squared. And I can't factor out a GCF here to make things better, right? So everybody see that factoring is a bad idea here? It's probably not even going to work. But even if it did, well, I guess it would actually if I did slip and slide. But no one wants to do slip and slide. Right? And let's just be real here. We don't want to do slip and slide. What do we want to do instead here, probably? Quadratic formula, absolutely. So if we just use the quadratic formula, what's that going to give me? Y equals, what goes first on top?
Negative B.
Negative B, which is, okay, so you guys tell me real quick, what are the values of A, B, and C? 4 is A, 23 is B, and negative 6. Okay, so if we plug that stuff in then, negative B would be what? There you go. Plus or minus square root B squared, well that's just 23 squared, whatever that is, minus 4 times 4 times negative 6. Aha, and what happens when I multiply by a negative there? Yeah, look at that, I get a negative times a negative, so I could make those positive, couldn't I? Right. All divided by what?
2A.
2A, which is 2 times 4, okay. Okay, so then we would have to just simplify all that stuff, right? So what's that going to give me then? So I'm going to get y equals negative 23 plus or minus the square root of 23 squared. Yikes, what is that about? What's that going to be? 529? What is it again?
23 squared is 529.
529, okay. So 529 plus 24 times 4 is just 96, all divided by 8. So I got to keep going. I got to turn that into one big number. $529 plus 96 is 625. What's the square root of 625? Anybody tell me? 25, yeah. And those are pretty big numbers, but how are you probably going to do this? And work with those big numbers, what are you going to probably use? Calculator, why not, right? So then what are my answers? Well, we're getting y equals negative 23 plus or minus 25 over 8. Okay, so what happens if we take the plus sign? We get negative 23 plus 25 over 8. What's negative 23 plus 25? 2. 2 over 8. Okay, that's 1/4. So there's one solution, right? How about if we take the minus sign? Y equals negative 23 minus 25 over 8. What's negative 23 minus 25? Negative 48, yeah. What's negative 48 over 8?
Negative 6.
Negative 6. So those are our two solutions, right? Are we done? Okay, what do we have to do on this one? Remember, it's easy to forget, but at the very beginning, we didn't have y's, we had x's, right? So what do we have to do? Substitute. We got to go back from y's to x squareds. So this answer really becomes x squared equals 1/4, or this one becomes x squared equals negative 6, right? So we're not quite done. We have one more step to do to each of those solutions. What's the last step here to get an x by itself? Square root, you got it. Okay, so if I square root x squared, it gives me x. What do I have to include when I square root both sides?
Plus or minus.
Plus or minus. And what's the square root of 1/4? No?
Square root of 1 over 2.
Square root of 1 over square root of 4. Let's split it up, right? Let's always split the square root. Square root of 1 over square root of 4. Okay. Well, what's the square root of 1? 1. What's the square root of 4? There you go. So I get x equals plus or minus 1/2 How many solutions are there? 2. So I got 2 solutions. Now I got to go back to this one. What's my one step? I have x squared equals -6. What's my only step to isolate x? Square root. Okay, good. So that cancels the squared, right? And that's going to give us x equals, what do I have to include? Plus or minus. And how do I deal with the square root of -6? Take an I out. Negative inside becomes I outside. And can I reduce the square root of 6? No, I'm stuck with that, right? So I get plus or minus the square root of 6 times I, right? There's my other solutions. So how many total solutions do I get? 4, and there they are. Okay. So what's kind of the trick there? I mean, why is this such a big deal? Well, really, I mean, the only thing that was different here than what we've done in the past is you have to make this substitution, y equals x squared, to turn this into a quadratic equation that we can solve the way we know how. And then once we're done with that, we just have to reverse that substitution and go back to x's and finish the job. Okay? Give me 1 to 5. How are we doing? Okay? All right, one more quick one, and this is actually a pretty quick one. That looks terrible, but does anybody see a way we can make this look much, much better?
Substitution.
Substitution. What substitution do you see?
2x plus 1.
Yeah, we could just let that equal some variable other than n, right? We have n's to start with, so we got to pick something else. Well, how about x? If I let x equal 2n plus 1, then doesn't this just become x squared plus 3x minus 4 equals 0? That looks a lot better, doesn't it? Okay, so now take a second and think about that one. What's going to be the easiest way to solve that quadratic equation? Vote with your thumbs. Can I point to a single x? No. Okay, so I can't isolate x. Cross off that possibility. What about factoring? Does that factor? I mean, should we try? We should try. Because look, a is equal to 1. So we should always try. And you could, honestly, you could just go right to quadratic formula. You really could. But there's more of a chance to make a mistake with quadratic formula than factoring if the magic numbers are super easy, right? So let's try factoring. It may or may not work, but we could try it. What would have to go there and there? X. Okay, now everybody together. My magic numbers would have to multiply to what? -4. And add to 3. Okay. Are there numbers that do that?
4 and -1.
Yeah, 4 and -1 would do it. So I'd have x plus 4 and x minus 1. So that's pretty easy then, right? What are my solutions? Okay, good. X equals -4 or x equals 1. But what's the one last thing we have to do? Flip back, right? Instead of x's, we need to convert that back to 2n plus 1. Every place we have an x needs to become 2n plus 1. So either 2n plus 1 equals -4 or 2n plus 1 equals 1. Okay, those are pretty easy equations to solve now. What are the 2 steps in order to solve for n? Subtract 1 and divide by 2, right? And you see why we can do that? Because in this little mini equation that we've got here, I can point to a single n, so I can just use inverse operations to isolate it, right? Okay, is this stuff kind of coming together here at the end? So we subtract 1, we get 2n equals -5, then you guys told me divide by 2, which we do, and we get n equals -5/2 is one solution, or how about over here? Same steps, right? Subtract 1 and divide by 2. So that gives me 2n equals 0. What's 0 divided by any number?
0.
Okay, so what's my final solution here then? 0. There you go. So those are my two solutions, either n equals negative 5/2 or n equals 0. Good? Make sense? Okay, I'm done. This assignment only has like 3 or 4 problems on it.